Hi everybody, it's Mr. C. Um, what I want to do is I want to finish what I'm doing right now is trying to get the pen ready. Let's try this again. Hey, what I want to do is I want to try and finish the notes on 9.5, day one. Unfortunately, on Friday we didn't quite get to the end of our notes, and there's a couple of special things that can cause us some problems, or at least cause us to ask some questions. So I'm going to start with that, and then we'll complete uh, the the 9.5 day two notes. Okay, so that you'll be ready to complete that whole section, and you will actually have a lot of practice doing factoring. Okay, I hope you guys gain some confidence over the weekend. Some questions, there's some things you still need to practice, but you're probably in good shape right now. Let's clear some things up. First of all, let's look at this problem right here. This one right here, what we need to do is we need to find something where we can multiply together to make 45, and we can add or find the sum to make 4. Um, Unfortunately, you might have spent quite a bit of time on problems like these, um, trying to find that right solution, and there's nothing. Okay, at least not right now. So this is unfactorable. You might see it labeled as prime, but basically, right now, we don't have a way of um, factoring this yet. Okay, so it's to be continued. That should, some of you didn't know that that was an option, and I'm sorry about that. But now that you know that some of them just won't fit into this pattern, you'll be able to say with certainty, look, there's nothing. When you multiply all the factors of 45, nothing will combine to make a 4. So let's keep moving. We have a couple other tricky examples here. Let's see if we can figure them out. I'm going to put my little X over here and figure out what I need to multiply times what I need to add together. You'll see here at the end, this C term isn't a constant this time. It's something a little bit different. I'm going to set up my two sets of parentheses, and we're going to get down to exactly what it is that would multiply together to make a 15y squared. Okay, I know I'm going to start with x at the beginning of each binomial because I see my first a term is a 1 for its coefficient, and so I'm going to have that at the beginning. I also see that the product is addition, and then the difference between the or the sum of it is negative, so that's a surefire sign that both of these are going to be negative. And then when I think about what two terms multiplied together will make y squared, I gotta believe that both of these are going to have a y at the end. When you multiply two different terms together, you're going to have two y's in order to make that y squared. So what multiplies together to make 15? How about, oh, I don't know, 3 and 5? Does that work for you? Let's do um, multiplies together to make 15y, adds together to make a negative 8. Let's try negative 3y and negative 5y. Does negative 3 times negative 5 make a positive 5, 15y squared? Why, yes, it does. When we add them together, does it make a negative 8? It sure does. So we'll have x minus 3y and then x minus 5y. That works. You weren't sure, you probably didn't know that this was going to be a possibility. We'd have more than one variable, but it's true. Let's see, look at the other one. Maybe this one will go a little bit faster. I'll set up my two binomials. I'll put my x up here. I need to multiply to make a negative 72k squared. I need to add together to make j k. You know, it's basically just a 1, a positive 1. So I know if I'm thinking right away, I've got j. One of these is negative and one of them is positive because the product is negative and the sum is positive. That just means one of the positive number is a little bit bigger than the negative. So what multiplies together? How about 9 and 8? That's easy enough, right? 9 times 8 makes 72, but it's going to have to be a k with it, right? 9k times 8k makes a 72k squared. But one of them will have to be negative and one of them will have to be positive. Now remember, when I find the sum, it's going to make a positive one. That gives me the clue that the positive 9, the 9 is going to be positive, the 8 is going to be negative, because that makes the sum of a positive one. So here's our solution, j plus 9k times j minus 8. I hope that this is making sense for you guys. That helps us to finish 9.5 day. If you were having some questions on that worksheet, now you should be able to finish that up without any problems. So I'm going to look back through here, looking at day 2, basic factoring and solving equations and finding zeros. I don't think that you're going to find any of this as new. It's just new combos, new ways of applying the things that we've been practicing. So when you look at your homework from last night, you'll go over this in class. I'm hoping the ones that gave you the most problems were number 4. And then any of these that had extra variables at the end, 12, 11, 15, like those are tough. 16. Ooh, yeah, this one's interesting right here. Backwards. So take a look at that, and then let's look on the second part. Again, there was another couple that were not factorable, and the ones here at the end can get pretty tricky. So if you need some extra practice, keep working on this, okay? If you got them wrong, go back and retry them now that you've been able to see how these are supposed to work, okay? So now for our next set of notes, there are some warm-ups here, and I'm going to work through these. I'm going to treat the t into 2 each one of these terms, -8, -6, and that equals 8t. I don't really want it to end up like this. I want to make it equal 0. So this is going to be 0 at the end. I also am going to combine like terms here, so I end up with what do I get? I get a -6d, and then minus, what is that? 24. That's equal to 0. And once I do that, I factor out a -6. That's a -6 times d plus 4, and that equals 0. So in reality, I don't really need to go this far. So I'll go back to the full screen here. I don't need to go this far. I don't have a squared variable and variable to the first power, so I can take this equation right here and turn it into 6d. -6d is equal to 24. I can just divide by a -6 on both sides, and I find out that d is equal to -4. So I can actually solve and find the variable. I don't have to factor it out and find the zeros. If I keep going, here I need to use the FOIL method. So I'm going to do 2y squared, and then that's going to be 10y. And then I'll do here another 3y, and then plus 15. So I put these together, I get 2y squared plus 13y. Hopefully this is getting a lot easier for you, okay? This should start becoming, if not automatic, then you should be getting a lot more comfortable with this. Here we want to factor these. I set this up, and I know I want to add together to make a -7. I need to multiply together to make a -18. So I'm trying to think, because this is negative, the product, That means one of them has to be positive and one of them has to be negative. Okay, that's how it has to go. My first term is going to be an x for both of them. And I'm thinking, you know what, 9 and 2 sounds as good as anything. If it's a negative 9 and a positive 2, I add them together, it makes a negative 7. Negative 9 times a positive 2 makes a negative 18. So there we go. X plus 2, x minus 9, and I've got it factored. Over here, this one's a little bit more tricky. I'll set up my two parentheses. I'm going to start with my x, and then I also know the product is positive, the sum is negative. It has to be that both of these are subtraction. Okay. I also have to know, since there's a y squared back here, then there's going to be a y for that second term. And now I have to figure out, well, what multiplies together to make 6? What adds together to make a negative 5? Boy, both of them are going to be negative. I don't know. How about a negative 5 and a negative 1? Nope, that doesn't work because I got to multiply to make 6. Add to make negative 5. So what about a negative 6 and a negative 1? When they multiply together, do they make a positive 6? When you add them together, negative 6 plus a negative 1, does that make a negative 5? No, that doesn't work either. So we got to take a different tactic. Some of you might have run into this. You're like, you were thinking you were supposed to know what it was, and then it doesn't work out. Well, try not to get too frustrated. Just go back to the beginning. What are some other factors for 6? Well, there's not that many. How about 2 and 3? Well, let's try that. Let's do, how about blue? How about a negative 2 and a negative 3? When you multiply them together, do they make a positive 6? Yes. When you add them together, do they make a negative 5? Yes. So there you have it. X minus 3y and x minus 2y. And there's our solution. You don't have to be Mr. Lightning Bolt on all this stuff yet, okay? Just make sure that you're going through the process and you are getting good at the process. You make mistakes along the way, that's okay. But if you're just like not even bothering to check your work, that's not good. Okay? Take it easy. Make sure you're doing things right. All right, our next example is going to be something kind of interesting here. They want me to solve the equation, and that means I'm going to have to use the zero product fraction. Okay, don't forget about the zero product. That means I'm going to factor all of this. Okay, what multiplies together to make a negative 30, adds together to make a negative 7. Let's see. What multiplies to make 30? How about 10 and 3? Okay, one of them has to be, since this is negative, the product is negative, means one of them has to be addition and one of them has to be subtraction. But the bigger number has to be the negative number. How about 10 and 3? Do they multiply together to make negative 30? Yes. Do they add together to make negative 7? Yes. And now, don't forget, all of this is equal to 0. So I'll change my colors. Let me go back here to, let's do red. That means n would have to equal 10, or n would have to equal negative 3 in order to make 0. You remember this? If n is 10, that's 10 minus 10 makes 0. That product is 0. Or if n is negative 3 and we have a positive 3, that makes 0. And the product would be 0 for all of this. So those are your two possible solutions. Over here, it's not equal to 0 yet. So we got to figure that out. We're going to add 23m on both sides. So now I've got m squared plus 23m plus 22. All right. I'll set this up. My two sets of parentheses. What multiplies together to make 22, but adds together to make 23? That is a crazy one. What do you guys think is a possible solution? And you're gonna run into some crazy ones like this, and you're gonna think, oh man, I don't know. Once you know that it's possible that it could be not factorable, you're gonna be inclined to maybe just jump to that right away, but that's not the case here. There's a really obvious solution. The simplest, easiest one is, well, it's both addition, and two of the factors of 22 are 1 and 22. When you multiply them together, they make 22. When you add them together, it makes 23. Be careful about that, okay? Be careful not to jump to this, not the prime option. So now, what are my possible solutions for m? M could be a -1, or m could be a -22. All right, so far so good. I'm going to do one more slide with you guys, and then I'll save the word problems for another video here, okay? They want you to find the zeros of the function. Well, guess what? This is going to equal 0. X squared minus 14x minus 51. What are the possible solutions? What are the possible factors? Well, x, let's see, what multiplies together to make a -51, and what adds together to make a -14. And your thoughts, you get your brain to work on it a little bit. I know that 3 and 17, when you multiply them, it makes a -51. If you add them and it makes -14, that means this one has to be negative, this one has to be positive. So we're going to go with x minus 17 and x plus 3. That would necessitate then that x would be equal to 17 possibly, or x would be equal to -3 in order for this to equal 0. All right, and then finally let's do one more. We'll get colors here for fun. This is going to make p squared plus 19p. And then once I move this over to the other side, it's going to be plus 34. And all that is equal to 0. Now what multiplies together to make 34 and then adds together to make 19? Well, man, I don't know all the factors for 34, but I'm pretty sure it's going to be like 17 and 2. 17 times 2 makes 34. When I add them together, guess what? It makes 19. And if all of this equals 0, then that means p has to be a -17, or p has to be a -2. Okay. If we take a sneak peek ahead, there's 2 word problems here. I'm going to make those into a separate video for you guys. Go ahead and take a minute, take a break, and then move on to those to finish your notes.